Okay, so for this video we're going to discuss converting from degrees to radians and radians to degrees. In order to do that, we need to create a couple of formulas for our conversions. It's worth noting that since we know a complete rotation in degrees is 360 degrees, and since we know a complete rotation in radians is 2 pi radians, then they must be equal. If it takes 360 degrees to do a complete rotation and it takes 2 pi radians to do a complete rotation, then 360 degrees must equal 2 pi radians. They're just different units of measurement. And if we solve each of these separately, one for degrees, one for radians, we'll create two necessary formulas for our conversions. In the first case, if we were to divide each side of the equation by 2, then we'll get 180 degrees equals pi radians. From here, we can start developing our formulas much easier now that we've gotten rid of that multiple of 2 that wasn't necessary. If we now divide each side of the equation by pi, then we'll get 180 over pi degrees is equal to 1 radian. This is our first conversion. Whenever you have 1 radian, you know that it is equal to 180 over pi degrees. So if you divide 180 by approximately 3.14, you'll find out exactly how much a radian is, which is just a little bit less than 60 degrees. From here, if we go back to this 180 degrees equals pi radians, and now we divide each side of the equation by 180, then we will get 1 degree is equal to pi over 180 radians. And this is our formula when we're converting from degrees to radians. So we can use these two formulas to do our conversions. Whenever you see a degree symbol, replace it with pi over 180 radians. Whenever you see a radian, convert it to 180 over pi degrees. Now, it is worth noting before we jump to these two examples, a couple of things that are noteworthy in mathematics. The first is that whenever a problem starts with radians or starts with degrees, it's generally advisable to continue going in that direction, not to convert it. But just know that it is up to you unless the directions in your problem specify otherwise. If you find it easier to work with one over the other, just know some formulas do require radians, like arc length, S equals R theta. Theta has to be in radians. You cannot convert to degrees if you're going to use a formula like that. The other thing that's worth noting is the word radians is implied. So if you ever see something that says the angle of 40, do not assume that that means degrees. It does not. It is assumed that you are dealing with radians unless you see a degree symbol. 40 degrees will be written exactly like this. If you just see 40, that implies 40 radians. We do not continually write the word radians over and over again. Okay, now moving to these two examples, we want to convert 50 degrees to radians. So to do that, we know that this degree symbol is representing pi over 180 radians. So we can change 50 degrees to 50 times pi over 180. And simply just simplify it. If we put this 50 over 1, it doesn't change the problem. We can put any number over 1, and it's still the same thing. And now we can cross-cancel because we're multiplying two fractions. Each of these numbers are divisible by 10, so we can just divide each of them by 10 to leave us with 5 over 18. which leaves us with 5 times pi is 5 pi, over 1 times 18 is 18, meaning 50 degrees is equivalent to 5 pi over 18 radians. Go ahead and take a moment, pause the video, and see if you can find a way to convert 9 pi over 2 to degrees using our formulas. Okay, trying this out, 9 pi over 2 radians, because it doesn't have a degree symbol, so 9 pi over 2 radians to degrees, we know 1 radian is equal to 180 over pi degrees. So we will get 9 pi over 2 times 180 over pi degrees. From here, we need to start canceling. Now, if you can just multiply these numbers in your head, that's fine, but generally it helps to cross-cancel to make it a little bit easier to work with. So notice we have a common factor of pi in the numerator and denominator. Let's cancel it out. We also have a common factor of 2 in the numerator and denominator. If we cancel it here, we'll be left with 1, just like this pi getting canceled leaves it with 1. Well, you don't have to write that. But when you cancel it from here, you'll be left with 90. So that gives us 9 times 90 is 810 over 1 times 1 is just 1, which leaves us with 810 degrees. So 9 pi over 2 is the same thing as 810 degrees, going from radians to degrees.